Hello everyone, welcome to Code to CloudX. Today we are going to start one of the most important topics in modern DevOps and microservices architecture, that is Docker and containerization. But before installing Docker or running containers, it is very important to understand why Docker became so popular and what problem it actually solves. Firstly, we will understand three major challenges in managing modern microservices based applications: deployment, portability, and scalability. So first, let's look at deployment. So this section highlights the challenge of deploying hundreds of small microservices efficiently. In large system, applications are split into many tiny services, and each service needs to be deployed, configured, and maintained. So the key questions here is, how do we deploy all these microservices with minimal effort and lower cost? Next is portability. So portability focus on moving applications across different environments such as development, testing, and productions. So in modern systems, applications may run on different servers, cloud platforms, or data centers. So the challenge is, how can we move hundreds of microservices between environments with less configuration, less efforts, and lower cost? Finally, we have scalability. So scalability refers to the ability of applications to handle increasing or decreasing demand automatically. For example, when more users access the system, the application should automatically create more services instances. So the main question here is, how do we scale applications dynamically based on demand while minimizing operational effort and cost? So now we understood the key challenges: deployment, portability, and scalability. So the next question comes, how did we try to solve these problems historically? So the answer that we need to look at the evolution of application deployment infrastructure. We will go step by step from physical server to virtual machine to containers, and containers to Docker. Once this concept becomes clear, learning Docker will become very easy. So let's start first from physical server. So first let's go back in time and understand how applications were deployed earlier. So earlier applications were deployed directly on physical server. That means one application equal to one physical machine. So firstly we will understand, if you remember earlier environment, whenever we deployed an application, we created a war file or jar file or EAR file, or that file contained UI code, business logic, libraries, everything as per the requirement. And we deployed it on an application server like WebLogic, WebSphere, Tomcat, or any other servers. But this approach had many problems. Very low resource utilization, hardware cost was high, scaling was difficult, and most CPU and memory remained unused. For example, you can understand like this: if an application usage only 20% CPU, the remaining 80% is wasted. So companies needed a better solutions, right? So to solve this problem, virtualization was introduced. Virtualization means running multiple virtual machines on a single physical server. So virtualization allows multiple virtual machines to run on a single physical server, and the component that makes this possible, that is called hypervisor. So each virtual machine will have its own operating system, its own applications, and this will be isolated from others, right? So a hypervisor is a software layer that installed on a physical server that allows you to create and manage multiple virtual machines on the same hardware. We told you that there are two types of hypervisor. type 1 hypervisor is also called bare metal hypervisor, and this hypervisor runs directly on a physical hardware. There is no host operating system on top of physical hardware directly. So type 1 hypervisor are best suited for production environment where performance, scalability, and security are crucial. And additionally, bare metal hypervisor are commonly used in cloud computing. Nowadays in AWS, Azure, they are widely used. And type 2 hypervisor is called hosted hypervisor. It is mainly used for development and testing. So although virtualization improved hardware utilizations, right? And virtual machine introduced new challenges as well. So you can understand each virtual machine requires a full operating system. Because of this, what will happen? High memory usage, slow startup time, heavy and resource intensive, more storage required. So the industry needed a lightweight alternative. And that's where containerization comes into the picture. So what is containerization? So containerization is a lightweight way to package an application along with its dependencies and runtime environment. So instead of running multiple operating systems, containers share the host operating system kernel, and that makes the container lightweight, fast to start, efficient in usage, and easy to scale. So now we understand that runs on top of virtual machine and helps us use resource more efficiently, right? So instead of running multiple full operating system like virtual machines, containers share the same operating system and run application in isolated environment. So in today's cloud environment like AWS, Azure, containers usually run inside virtual machines, and orchestration tools like Kubernetes manage these containers at scale only, right? So now we understand that containerization helps solve many problems of virtual machines. Containers are lightweight, start faster, and multiple containers share the same operating system kernel. So now the question comes, can containerization replace the hypervisor? No. The answer is no. They don't replace each other. They actually work together. How? So hypervisor provides hardware level isolation. It creates virtual machines and each virtual machine has its own operating system, right? On the other hand, containerization works at the operating system level. Containers share the host operating system but provides application level isolation. So you can think hypervisor like an apartment building. The physical server is the land and the hypervisor is the building. And each virtual machine is a flat given to a customer. Now, inside each flat, there are multiple rooms. And these rooms are containers where different applications run. Okay? So, hypervisor gives strong infrastructure isolation and containers give lightweight application level isolation. Got it? So containers did not replace hypervisors. They solve it different problems. So now the question is, how do we create and manage containers? So this is where Docker comes in. So Docker is like a shipping container. When goods are shipped around the world, they are placed inside standard containers. And these containers can travel on ships, trucks, or trains without changing anything inside. Docker does the same thing for software. It packages the applications and everything it needs to run into a container. So a Docker container includes the application code, required libraries, runtime environment, system tools, configuration files. Because everything is packaged together, the application runs exactly the same either on your laptop, in a server, or either in the cloud. This removes the famous problem, it works on my machine. So there are two important concepts in Docker. First is the Docker image. So a Docker image is like a blueprint or recipe that contains instruction to build the application environment. And second is the Docker container. So container is the running version of that image or running instance of that image. Think of it like this: image means recipe or container means actual disk or running instance of that image. So quick recap. So as we discussed in the past, developers used virtual machines. Virtual machine includes an entire operating system, which makes them heavy and slow. Whereas Docker containers are different. They share the host operating system and making them lightweight, fast to start, and easy to scale. So in this video, we understood the complete journey of application deployment, from physical server to virtual machine and finally to containers and Dockers. In the next video, we will start working with Docker practically. We will install Docker and create our first container step by step. So if you found this video helpful, please like and subscribe to the channel. See you in the next video. Thank you.